So our clients had a problem where they'd licensed a proprietary pricing model and they needed to price a bunch of securities data. Our job was to make it faster and cheaper to run. So what we've done is we've taken that model, we've essentially duplicated it thousands of times within AWS, and we run the calculation in parallel. So now what happens is instead of running one big calculation, we now run 1,000 calculations in parallel, which gives us a massive speed increase, up to about 2,500% increase. The original system, when our client gave it to us, was based on a large Docker container running in AWS as an EC2 instance. And what we did was we took that Docker container, we put it into a AWS Lambda, which allows us to run the compute in parallel. And then in front of that, we've got a few queues and a couple of other AWS Lambdas. So the idea is that as a calculation comes in, the first Lambda takes over, splits the calculation up into thousands of pieces, and then all those pieces are run in parallel, and the calculation's put back together at the end. We use S3 for storage, and that way we can easily pull the data in and out of the Lambda. The Lambdas are cheap, and you can get lots of them. So unlike a EC2 instance where the cost is a lot more expensive, a Lambda has a maximum runtime of about 15 minutes. So you can spin them up very quickly, run your calculation, and then they will shut down. And within AWS, we can have 10,000 at that time. Our limit was 10,000 Lambdas, which meant that we could scale to quite large speeds. The Lambdas would only be running for about 30 to 90 seconds. So we'd spin them up, let them run the calculation, and shut them all down. S3 allows you to store lots of data very, very cheaply. The entire aim of the system, or one of the aims, was to build a system that essentially was zero cost at idle. You can't truly get zero cost, but the idea is that when the system's not running, you're basically only paying for storage costs, which is S3. The rest of the time when it runs, you only pay for the small computing power you need during the calculation, and then everything shuts down again, and then you're back down to zero.